Volumes of prisms. Volume is a measure of how much space a three-dimensional object occupies. It is measured in cubic units, for example, centimeters cubed, meters cubed, or millimeters cubed. If we're looking at the volume of a fluid, typically it's measured in liters. The liter represents the volume of a cube with a side length of 10 centimeters. So it represents 10 centimeters times 10 centimeters times 10 centimeters, or 1,000 centimeters cubed. And the other thing we need to know is the word capacity tells us that's the greatest volume of liquid a container may hold. Volumes of prisms and cylinders. First, we need to know what they are. A prism is a three-dimensional object with two identical parallel bases that are polygons. So the bases could be squares, rectangles, triangles, hexagons. A cylinder is a special three-dimensional object, very similar to a prism, except for its ends are circles. The formula for the volume of any prism or cylinder is always volume equals area of the base multiplied by the height. For example, if you consider the rectangular prism in the diagram, we see that we have two rectangular bases. On the top, we have a dimension of 3 centimeters by 2 centimeters. And we have a height of 5 centimeters. In order to find the volume of that prism, we have to realize that volume is equal to the area of the base multiplied by the height. And the area of a rectangle is length times width. So that's where the formula length times width times height comes from. In this case, the length is 3 centimeters and the width is 2 centimeters, and the height is 5 centimeters. And we use our good friend BEDMAS, multiply across, and the volume is 30 centimeters cubed. In part B, we see we have a triangular-based prism. Even though it's not sitting on the triangular basis, we see two identical shapes joined together. Again, the formula is the area of the base multiplied by the height. Now for a triangle, that would be 1/2 base times height. In this case, the base is 6 and the height is being shown as 4 centimeters. The height you see in this equation is the height of the prism. And I've differentiated in the formulas by referring to the triangle and the prism as subscripts. So the base of the triangle is 6, the height is 4, divided by 2, multiplied by the height of the prism, which is 10. And my good friend BEDMAS tells me to do inside the brackets first. So I end up with 24 divided by 2, which is 12. And when I multiply that by 10, I get 120 centimeters cubed.